So when I look at this graph, what I see right here is it goes up right here, comes up, comes down because I can see a little local minimum right here, but it bounces back up. But it never intersects that x-axis again. So when I see this, I only have one real zero. But when I look at the power, how many complex zeros are there going to be in this? 3. So what that means is there is going to be an imaginary or a conjugate pair of imaginary zeros. Okay, so if you notice that, okay, so if you go through and solve, and let's say I did this by hitting solve, and I set my function equal to 0. Because I've already entered it in my y editor, I'm just going to call it y1 of x is equal to 0, solve for x. And when I do, all I get is one solution. I get negative 3. So I know that that's one of my zeros. Okay, that's great. Okay, but I was expecting 3 of them. And so when you look at this, again, if you look at the graph of it, the graph isn't of the form that would show a bounce, or isn't of the form that would show a multiplicity of 3. And it looks like it's a multiplicity of 1. So I know that I have some non-real zeros. Okay, so if you recognize that you have non-real zeros, what you can do from the home screen is instead of using solve, you can call csolve. So if we put the letter C in front, this is now going to solve it in the complex number system, which includes imaginary numbers. Okay, and now when you do that, you see the imaginary zeros. So 1/3 plus 2/3, or root 2 over 3 root I. So that's 1 over 3 plus root 2 over 3i. And because this is a conjugate pair, which I'll talk about here in a second, my expectation is to see 1 over 3 minus that same root 2 over 3i. So 1 over 3 minus root 2 over 3i, same terms, opposite sign between. Oops, and this is 0. And then the same thing here. These are ordered pair. Okay? And so you can enter them in that. Okay, in this one, they just asked you for the zeros. It may not, again, it will either be ordered pair or just a list of the x coordinates. But here, you're going to list them as x coordinates. Okay. When you write the complex zeros, complex zeros have to be written in this form. A plus bi. It can't be written in the form something plus something I all over a denominator. What has to happen is if you get a solution where, let's say you say 2 minus 5i over 3, what's going to happen when you enter this online is you have to distribute that out, put the entire real part first, so 2/3, and then put the entire complex part, so 5/3 I. And it needs to be written in this form. Okay? Otherwise, it's not going to mark it correctly.